నమస్కారములు. నమో నమః. శ్రీ గురుభ్యో నమః. ఓం నమః శివాయ. Okay, today is the second day of our classes on Vedic mathematics. Yesterday was the first day and we have learnt a few mathematical operations. Today we will revise them and also learn little more. Those I will keep the mics open. You can unmute and request for any questions and answer. If possible, you raise your hand instead of interrupting. Interrupting is also okay, provided it is urgent. Okay, now let us start with Vande Mataram and then Prarthana. Chala Chiripav garu, please.
Vande Mataram, Vande Mataram, Sujalam, Sufalam, Malaya Jasitalam, Sasya Syamalam Mataram, Vande Mataram. Suprajosna pulakitayamini pullakusumita drumadala shobhini suhasini sumadhura bhashini sukhadam varadam mataram Vande Mataram Vande Mataram.
Vande Mataram. ధన్యవాదములండి చాలా చిట్టిబాబు గారు. Now let us request Chavali Vishalakshi garu to chant Prarthana, please.
Sarvebhya Namaskaraha. We will meditate for a minute and then we will start the prayers. Please close your eyes. Relax your body and focus on your breath. Om Gananan Tva Ganapatigum Havamahi Kavim Kavinamupamashravastamam Jyeshtarajam Brahmanam Brahmanaspat Anashtrunvannodibhisida Sadhanam. Om Shri Mahaganadhipataye Namaha. Om Prano Devi Saraswati Vajebhirvajinivati Dhinamavitrayavatu. Om Shri Mahasaraswatyai Namaha. Gurureva Gatir Gurumeva Bhaje Gurunaiva Sahasmi Namo Gurave. Na Guroh Paramam Shishurasmi Guroh Matirasti Gurau Mama Pahi Guru. Jnananandamayam Devam Nirmalaspatika Krutim आधारं सर्वविद्यानां हयग्रीवमुपास्महे श्रुतिस्मृतिपुराणानाम् आलयं करुणालयं नमामि भगवत्पाद शङ्करं लोकशङ्करं शङ्करं शङ्कराचार्यं केशवं बादरायणं सूत्रभाष्यकृतौ वन्दे भगवन्तो पुनः पुनः ईश्वरो गुरुरात्मेति मूर्तिभेदविभागिने व्योमवद्व्याप्तदेहाय दक्षिणामूर्तये नमः असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतं गमय ॐ शान्ति शान्ति शान्तिः मातृदेवो भव पितृदेवो भव आचार्यदेवो भव अतिथिदेवो भव ॐ सहनाववतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै ॐ शान्ति शान्ति शान्तिः श्रीगुरुभ्यो नमः हरिः ओम्
ధన్యవాదములండి. చావలి విశాలాక్షి గారు చాలా బాగా గానం చేశారు. Now let us request Gautham ji to continue the webinar, please. I will unmute 1 minute.
Thank you. Sarvebho Namaskara. I will start the share screen. Oh, host disabled participating screen sharing.
Oh, you are not the co-host. 1 minute. So you could do it now.
Yeah. So yesterday, we went, we completed the multiplication near a base, and so as per request from Chalachitra, so let me just have a brief of the what we have done yesterday. We first discussed about the origin of counting and so on, and then how the positional, this is most important, how the positional number system came in India, and then concept of zero and calculation of, with zero. And then we went to the base concept, and then we went to place value and face value, and how the negative face value came to fraction, decimal notation, and vinculum is the negative face value. Negative place value was that decimal, and negative face value is vinculum. Now there are various numerical symbols in various states of India, as well as there are symbols of numbers for other countries, which all can be enabled. They are all enabled for Excel, in Excel to calculate using those numbers. Now, what is Vedic mathematics? So there is some link here in the Kalpa in Veda, and then we went to up to that how the it gives more control on number system. We discussed, and the book was there. Sorry, I didn't give the link. Anyway, some people might have tried it. Vedic mathematics by Bharati Krishna Tirthaji. This is the best I have seen. There are some 16 sutras and 13 subsutras, and some meanings of there were there. Like what we will be using most is Ekadikana Purvena, one more than the previous, and Nikhilam Navata Saramag Dasata, all from 9 and ultimate from 10. The rightmost digit from 10. I mean, subtracted from 10, this means. And Urdhva Tijagabhami, that will be also a multiplication method. We'll discuss this one in course of our work. And there are some meanings are there. Now, what are the scope of Vedic mathematics? It is not just only arithmetical computation and multiplication division. There can be higher things like calculus, integration, factorization, and differentiation, and so on. Now, arithmetical computation is started, and how vinculam we give the concept. Basically, vinculam is nothing but we all use it. I'm not telling that we do not use it. We use it in different notation, but we do not use this notation. What I meant to say, like suppose when we subtract 143 from 143,000. What we do, the way we do subtract, you will find that ultimately the effect is with something with all zeros, we are subtracting a number. We always subtract the last one, it is equivalent to subtracting from 10. And we something called borrow and all these things are there, and it effectively it means that subtracting from 9. So it is nothing new actually, we all know it. But the way it is put actually, it is in a sentence, the Nikhilam Navata Sarma Dasata, we never did that, but did that sentence, but we all know it. So therefore, these are vinculam is nothing new, except in that always this vinculam notation means you thing is it is a negative number placed in that particular, maybe maybe 10, maybe 100, and so on. So it is a negative number placed in that place. So it is equivalent to subtracting with the rest of the things like that. So these examples are there. All if we subtract all with say 3 and all zeros, it will obviously you will find that the last one from 10 and all will be from 9, and then when it ends, it will be reduced obviously, because then again borrow are there and so on. We simply here we take that Ekanunana Purvena, but actually we know it that is to be reduced, and obviously from doing opposite it has to be increased. So we all basically now vinculum you have this thing, and now there's one example was there how use of vinculums can make it the calculation easier. Here the explanation also I had given that. So 3, 9, 6, 7, 8, all these things purposefully I kept above much above 5. So if it is more than 5, the use of vinculum is actually effective. So when we add all these things, it will be a high amount of carry will be there. We have to calculate a lot. Whereas if we do the negative ones, you can do this way also. I don't know. We know this way. It is better actually. Instead of writing all throughout like this, we simply put a bar on this. This is the only difference with vinculum with our normal conventional. Here what we do when you take as negative this one, and these becomes obviously it will be small because more than 5. If we do it negatively, say it will be.
Sir, may
smaller.
I ask a question? Here,
Yeah.
sir? May I ask a question? Sir, yeah, in this chart, you have written 27, second row, 27,689, 32,311. And we put like 28,311 and banculum only on 311. So it will be 28,000 minus 311 and resultant will be same 27,689, like that.
Yes. Actually, if you do subtract 2311 from 30,000, the result is this one. Okay.
So my question is whether we can put here 28,311 and here this banculum instead of 2,311 it should be only 311. So resultant will be the same. Can we put like that?
No, but you are telling the 28. So why to use more than 5? The 8 is more than 5. So why not reduce it? That is the idea.
Acha, 28 is more, 8 is more than 8. So
8
it should be
is more
lower
than
than
5.
8.
8 is more than 5. So we can better to use, better to use vinculum up to 7, reducing up to 7. So
Up to
here,
7. But it is
at
not
any point
become,
you can do, you can keep something more than 5, but why to? Basically, it is better to make everything more than less than 5. So this is all the digits become less than 5, even though they are negative. So when we add them, it becomes easy. See, there is no carry here involved. So all these things are without carry. We added that, and finally we reconverted back to this one non-vinculum number. So it will be reduced, obviously. It will be reduced. Here it got increased because of this reason, and it is reduced. So we know all this. It is not that it's not known to us. The explanation shows that. Okay. So only thing is that notation is different, vinculum notation.
Okay. Thank you.
And here you see that here how you did it. Here purposefully I mixed that. So wherever required, some numbers will be there, which is less than 5 and more than 5. These are mixed. So accordingly, we have put that, and you will see that a lot of things are got cancelled. Like 4 will be cancelled with vinculum 4 means -4. 2 minus 1 will be 1. So it will be very easy compared to had we done with that this one with high amount of carry, it will be involved. So here there is no carry, all these things are cancelled, and finally even arrive the result just
Sir,
like that. Because there is
in this chart, can you explain this part, sir?
which part?
40,300, 40,300 port 54,000.
No, don't say like that. No, it is not.
This I understand. Sir, this I understood. But
40,304. This expression part.
minus 301. From where it has come?
Minus 301 came from the. I put the arrow, na. I came from there. I'll tell you. Actually,
Okay, 301.
In the exploration, I actually crossed this thing. No, actually, this 301. This is the minus 301. This we put it here. Therefore, I put this arrows.
Okay.
This cross arrows I put. But this can be explained like, because when we are evaluating that thing, effectively you are doing like that. So that's what I told. That I grouped it with plus and positive and negative in the same place. So therefore, it can be a crude explanation actually. So therefore, I put the arrow, na.
Because here 334 is there, and then it is coming 301. Here it is coming 1030.
1030 is here. Minus 1030 is here. Minus 2040 is here. Okay. And minus 204 is here. 0204. Okay. Okay. It is just a crude explanation, but actually this is here the more clear expressions are there. Here I told that how by crossing it, you can, if you do the subtraction, this becomes more easier actually. That's it. Nothing more.
Okay. Okay, thank you.
This is a very small thing that you do this with the next number and then 25. So it is a very, normally people use it sometimes as a shortcut. Now come to the revision of this one, multiplication near a base. So base actually will be the nearest power of 10. And we just have to do here, in this is case of below base. So we did like that, and we multiply this thing and then subtract, cross subtract this 97 minus 7, or we can do 93 minus 3. So in both cases it's 90, and the 3 into 7, 0.3 into the 7 is 21. So it is the result. So that way, same way, if we increase the number of nines, or increase of number of nines here and number of zeros in that second part, there is other part. It could have some carry also, and that carry has to be then. Suppose there had been a carry. Suppose this is there is one was there. Suppose something is these are more actually numbers. So that one could have been added to this 3, not expand. This means this carry will not make it more, number of digits will not be more, obviously. So this has to be added to this part. Had there been any carry. Here I took the simpler cases. There is no carry. I hope you tried this thing and with your own numbers. I told you yesterday. Now here above base is the similar thing exactly. There is nothing particular in that difference. So in the same way, we multiply this second part and multiply this second part here, and first part is this multiplication. I mean, added to this by adding we get 128, and algebraic expression is there. That is already. This is my n minus n plus a, and n plus a, and from there we identify that a. Similarly, this is n plus b, and from there we identify the b, and this becomes n plus a plus b. Either way, you add the same thing, obviously it will come to same cross addition. So n plus a plus b, and this is the AB part. So that way, the whole algebra is complete. I hope you tried that thing. With trial, it will not be problem. Here, some problem comes when one is less than base and another is base, more than base. So it becomes negative. And with negative, we follow the vinculum procedure. We finally clear the vinculum, and result is, we got the result.
Okay.
So here also examples was there, and this algebraic expression is there. There is some challenges may come. Another here, no, there is no other challenge excepting that vinculum. And here actually there is another case is sub-base. Sub-base is near about a some multiple or a multiple of a base, means that power of 10. So here we took the example which is near 500. So we did with that 500, and finally we divided it. And when we take the base 100 to base, and it is 4 times, means 5 times, near the 5 times of that, means near 500, we finally multiply with it 5. The result is same. And here we did also the same thing, this example. And here actually, here we showed that there is a carry involved here. 17 to 7. Place is 19, but there is a carry because there only 2 digits are allotted, because it is near the base is only have 2 zeros. So this one gets added to this one. So it becomes, both cases it becomes the same. So instead of 2450 and then 19, it becomes 245119. One is negative, of course, carry. Now the challenge came here when this also is similar to that one. Challenge came when we got a half. That half has to be tackled properly, depending upon the position of the half, or say 1/4. It will be half in the position of 10 means it is 5. Half is the position of the hundreds position, it is 50. Half in the position of 1000 will be 500, and so on. Similarly, 1/4 will be 25, and so on. In case of 100, this one, I hope you tried this thing. This is 50, and we add these things 160, so it becomes 210. and 210 added to this 600. This 6 is actually position of 600. 600 plus 210 becomes 810. So explanation is there with how the sum multiple or the multiple it is explained. Okay, I hope that it will not be a problem. You again try. I mean, tomorrow also you will take that. Now,
Sir, if you can explain one slide, squaring number ending with 5.
huh?
One
Which
slide,
one?
please. A squaring number ending with 5.
Which squaring number?
Your one slide is headed, heading is there, a squaring number ending with 5.
That was that people actually squaring a number ending with 5.
That please explain.
Oh, it is nothing that 15 square. Here we do always 15 square will be anything ending in 5 will always end in with 25. But what to write before 25? Before 25 is that the first digit and its next digit. We multiply.
Achha. First digit and next digit.
Next digit. And then we simply put 25, nothing else. See here, 2, so 2 into 3, 3 into 4, 4 into 5, 5 into 6, 30 into 31, 302 into 303, then 25. So no problem.
Okay, sir. It's clear now. Thank you.
So we come to this one. Now today we are discussing a fresh topic, that is general multiplication by Tirjak method. Now, actually, it is in the last that we have compared this thing, our conventional mathematics. Our conventional mathematics, what we do, now ignore for the right part. What we do actually multiply the rightmost digit with all the whole of the top line. So we got this one. Then we shift one, and sometimes the child will put a cross like this, so that we actually basically shifting towards left. So it is actually that way we are multiplying everything with the rightmost digit, then the next, then we say the next, and row by row we fill up that with shifting with towards left. And the explanation is, in the conventional method, explanation is that everything with that, if suppose there are two numbers, 100A plus 10B plus C, this notation, those of you who understand this example, in the notation, 100P plus 10 this Q, okay, 10Q plus R. So this one, everything we multiply with R. And then everything in the second line, everything we multiply with the second one, Q, the next digit here, this one, the R and Q, and then last one with P. And we further shift, we always shifted left. That means actually we are multiplying with, this will be with 10. Shifting actually, shifting means multiplying with power of 10. So it will be multiplied by 100. That way we did. However, in Urdu Tirjak, what we do, we group according to the power of 10. So this was unit, this was tens digit, this is hundreds, this is 1,000, and this is 10,000. So, and then we did accordingly. So it shows that there is a paper on that doing this way actually is more computer time consuming, or the more process consuming, so that finally this is more efficient. And when there are billions of such multiplication, this actually becomes, even that one electronically, it saves power if we use it more efficient way. So that's what the circuitry change are being done to incorporate. The suggestion is there. If they do it, the people next level of chip, if they incorporate this Tiryak method instead of the conventional multiplication, the millions and billions of multiplication are always taking place. Even to display, I told you yesterday, even to display a number or a dot, a picture on a pixel or picture element on a particular position of the screen, it requires multiplication, lot of multiplication. So not only in case of real multiplication, but always multiplication is happening, and such billions of devices, mobiles, computers, and so on, so they are performing. So there is more efficient method is there, the Tiryak method. So it will be saving power ultimately. The paper says like that. Showed some experiment with how the delay is reducing and so on, power is reducing. But anyway, so this is about that was about this one, efficiency of this. Now, what is procedure? I first start with the simplest ones with 2 digits. So instead of multiplying everything by 5, what do we do? I first multiply 3 with 5. The result is 15. So 15, that way I write 5 here and 1 is below. Now you do cross 1. Second step is, I have shown this one, this cross. What do you do? Second one is cross. 4 into 5 plus 3 into 6, 2. So this becomes 26. 26 is here. 6 to the right and the above, and 2 below in the left. Okay. Third one, which is this group. Hundreds digit with AC, meaning this leftmost digits. 4 into 2 is 8. So finally we got the carry. We simply added it here, 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 added, and we got real. Is it clear? So this is by grouping. Let me take example, higher digits. Higher digits also, 2 numbers are there. I've shown that how these 2 numbers will be this group work. There are with arrows, these kind of things are drawn here, like what I will explain it. The rightmost will be 4 into 2. In fact, here it doesn't matter the way it started. Even you could have done like this. I tell you, you do first 4 into 2, put 8 here, and then you 4 into 5 plus 3 into 2, put 6 and 2 here, and 3 into 5 is 15, you put that. This way you can do from right to left or left to right, it doesn't matter. Here, 4 into 2 is 8 here. And then we did 1 into 2 plus 4 into 5, which is 22. Okay. To the carry we put in the left and in the below line. Then there is this group, hundreds group. How it is 3 into 2 plus 4 into 3 plus 1 into 5. This way. So this method I have shown here. 3 into 2 plus 1 into 5 plus 4 into 3 is equal to 23. 23, we put like this, 3 here above and 2 below left. And then we come to the thousands digit, which is 3 into 5 plus 1 into 3. 3 into 5, 3 into 5 plus 1 into 3. Number got changed. Oh, no, sorry. I put it other way. Sorry. 3 into 5 plus 1 into 3 here. 3 into 5 plus 1 into 3. This one. And then finally 3 into 3. and you put 9 here. This 18 was there, you put 18 like this. This is 18. And then finally you add, so it becomes like this. It's clear? Should we go to the next level example? 5 into 5. Earlier it was 3 into 3.
Gautamji, if you go to the last one, see the first 3 into 3, 9 is there. Okay, 9, 8, 3, 2, 3, 2, 32. It is actually, I think, 23. 8, 1, 8, 1, 18. And you put 3, 2, it is becoming 32. It is actually 23. Isn't it?
23, this one. It's 23 only.
But
not 32, it's 23.
Okay. Thank you. Sorry.
Yes. So it must be clear. You just practice it. Just conventional, as I told that it is proved actually more efficient here that you put this way. Only thing is that you either have to write separately or you have to remember it. Those of you, there are people who have seen that they can remember this doing 3 into 2. They can do 3 into 2 plus 1 into 5. They can remember easily. And some people have to write it. So that depends on the practice. So it becomes that very easy. And then finally, we got the result. Now, a bigger example I put, which 5 into 5.
Gautamji, there is one person, Hemalata Garu, you can ask the question.
Yeah, thank you, sir. Sir, can we combine 2-3 methods here in Vedic mathematics? Like you're using Tiryag method here. Now, when you got 9, 8, 3, 2, 8, big numbers, can we use vinculum also here?
I finally have discussed that.
Okay.
So if there are bigger numbers, we use Tiryag method but use vinculums. Even you can use your conventional method using vinculum. That also will make it easy. The last I discussed this thing. I'll tell you.
Okay, sir.
I say now I come to 5 into 5. 5 into 5 will be very big, obviously. There will be so many up to. You need 100, you need 10, 100, 1,000, 10,000, lakh, 10 lakhs, then crore and 10 crores. So this 83 crore, 51 lakh, 27,702 becomes results. Obviously, it will be like that. There are 5 digits. Now, here you to should we say from right to left or left to right? You can do anyway. 2 into 3 is 6. 2 into 5 plus 3 into 3 is 19. So 9 is here, 1 is here. Then we did 2 into 6 plus 4 into 3 plus 3 into 5. This is 39. 39 is here. Okay. Then 2 into 4, 3 into 3, 3 into 6, 4 into 5. This 4, this one. 2 into 4, 55. So 55 is here. Now it becomes 4. Now it is a 5 level. 2 into 2 plus this 1 into 3, 3 into 4, 3 into 5, and 4 into 6, middle to middle. This 4 into 6 is here. So whole thing is here. The result is 58. We put it, 58 is here. Okay. And then gradually I'm shifting towards right. 3 into 2, 1 into 5, 4 into 4, 3 into 6. So it is here, 45. 45. Now we're shortening it again. 1 to 2 to 3, 4, 5, and then again 4, 3, 2, 1. Now the number of digits will be only number of multiplication will be reduced to 3, going towards right. 4 into 2 plus here 4 into 2 plus 2 into 3 into 4 plus 1 into 6 is 26. 26 is here. Now again coming to only 2 digits, 3 into 2, 4 into 10 is 10. So it is 1, 0, 10. And then finally 1 into 2, we write the digit. And finally we add. Okay, respective carries were added to above the get. Sometimes we get maybe in the hundreds we can get. And that can be avoided by using vinculum. Nicely asked by Dr. I forgot the name. So you very nicely you asked that what to do with bigger number. So solution is vinculum. So it will be reduced. So they are here. I hope it will be explained. You can see it later also. I'll go to the next one. So here you have taken an example, the same example, in fact, the same example. I did it with vinculum, some vinculum. Like only one scope of vinculum was there. Instead of making it 56, we reduce it to this 4. Suppose 56, it is not less, more than 5, it is 5 itself. But when we do it, 56, if we do, want to write, I have to write 6 and 4 vinculum. So this doesn't serve my purpose because 6 became more than 5 again. So here you have to take with this all the things, this one. So it becomes 4 and vinculum 4, vinculum 4. So that is the idea why I told that it is greater than equal to 5. Sometimes it is required that we cannot keep 5 because next digit is more. So this will make the 5 as 6. It will increase. So obviously you have to use sometimes 5 also you have to do it vinculum. So this way, here also I got this same thing is repeated actually. This whole thing I got, this could have been much more actually, even 3 digits. But when you reduce to vinculum, and we find that it becomes 4 into 4. So this same way you can do that 1 into 2, 3 into 2 plus 1 into 2 is 10. I earlier got it. Now 4 into 4 minus 3 into 4. Okay. What happened? 16 minus 12. So it becomes 16 minus 12 is what is everything? Oh, no.
Minus
I'm
4.
sorry. No, not that. I'll tell you. From the beginning. 1 into 2 is 2. 3 into 2 plus 1 into 4 is 10 here. Here, 4 into 2. Okay. 4 into 2 minus 1 into 4 it becomes 4. 4 plus 3 into 4 is 16. So this 16 is here. Okay. Now 3 into 2 minus 1 into 4 means that it becomes 2. 2 and then 4 into 4 is 16 and 3 into 4. This contributes another 4. 2 plus 4 is 6. 6. There is no carry. See, this is 6. There is no carry. This is 0. So by using vinculum, the number is getting reduced. Into 4 plus here the next one will be 2 into 2 plus 1 into 4 plus 3 into 2 minus and so on. It will be reduced to minus 8. Yeah, it has got minus 8. Then also next also will be minus 8, minus 4. So this only carry was this. So if I add that, and then you clear the vinculum, this or 4,888 will be 3. 4 with 4,888 will be 3 with 512. That is the only vinculum has to be cleared. then we arrive at the same result. It is not better to react that way. It is not that the use of vinculum made it easy. You got always that I have chosen the smaller digits. It could have been 8, 9, and 7, and so on. It could have been very big numbers with there be another rows of carries could have been there. Again, we shift towards left and below. So that could be avoided totally using vinculum. Very little carry will be there.
Sir,
And
one
finally,
question, sir. Sir,
Huh.
one question, sir.
yeah.
Can you explain again how this 356.42 has come 444.42 in vinculum?
Oh,
350. Please explain again.
this
How
one,
it has
3, 5,
become
2.
440. 356.42 in vinculum, it has become 444.42.
Oh, acha. No,
Please
4, 2.
explain.
I didn't touch this one. This is not touched.
Okay.
I touched only this one.
But 356 has converted into 444
444.
above bar. So
it is
vinculum,
actually
how it is?
400, okay, minus 44. 400 minus 44 is how much? 356. So that is the
Okay,
idea.
sir. Okay, sir. Now it is clear. Thank you very much.
So we know all these things, but using vinculum notation, if you do like that with negative place values, negative phase values, what will happen? You see that in the this kind of multiplication, complicated multiplication, it gets reduced. Finally, it will be some negative numbers will be there. Doesn't matter. No, doesn't matter. But you avoid carry. There could have been carry in multiple levels carry. You avoid that carry and you get a vinculum number. They do finally clear the all vinculums and you get the numbers, a result. Here, again, comparison between multiplication methods. What we do, and we took, I took purposefully a higher number, with 8, 9, and so on. So 889 into 898. Urdhva Tirjagabham. How to do? Urdhva Tirjagabham, if we do it normally without applying the vinculum, 8 into 9 is 72, 72 is here. 8 into 8 plus 9 into 9 becomes 145. See, 8 into 8 plus 9 into 8 plus 8 into 9 becomes 208. 8 into 9 plus 8 into 8 again become, how is that? 8 into 9 plus 9 to 8 is 136. I put it like this. This way. It is 136. This way I put. Because keeping it 1, I can keep here as well. It doesn't matter because nothing is there in the left. And 8 into 8 is 64. I put it 64. I could have write 4 here and 6 here. That's also same thing. Ultimately, this one. So we added this thing, it came to like this. So it became very big numbers with carry up to hundreds digits. Whereas we convert it into vinculums. 889 is 1000 minus 111, and 898 is 1000 minus 1000 minus 102. 0 doesn't matter if you put a bar here or the whole thing is bar. It doesn't make any difference.
But
Oh,
from your logic,
Huh.
this 136, when it come 136, then one should have been in the third row, left side.
Yeah. Actually, we took a liberty. That's because there is nothing in the left. I could have done, yes. Suppose this is, I cut this. No, it is not there. What I do? I put the one here. Okay. Put the one here. Put 1 here. And the 64, I put the 6 here. Here we put 6. And here is 136, this one. 6 will come here. 4 is here, 64. So 6 will come here. And this 136 will come here. It's the same thing actually.
Okay.
So since there is nothing left, I took the liberty of putting it in the same row.
Okay.
Now,
Okay, thank you.
when you do it, this one by Urdhatu Jagabham, but using vinculums, so how see? There is no carry at all. 1 into 2 minus minus 1 into minus 2. Vinculum 1 into 2, 2. 1 into 2 it becomes positive 2 plus 0. So again 2. 1 minus 1 minus 2 becomes 2. This also is 2 into 3 and this plus 0. So 3. So that like that way it will be minus 1, this one, this plus this plus this plus this, or will be minus 2. This plus this will be 0. 1 into 0, 1 into minus 1, and minus 1 into minus 1 becomes 0. So 1 into this one is minus 2. And this 1 into 1 is 2. So we arrive at that. When you clear the vinculum, you directly arrive there at the result. 1000 minus 202 is 798. Then this 322 is outside the vinculum. So this becomes 7. We arrived at that. Now Nikhilam Navatas Charamodasata. How will make it? 889 is, see, it will be, she's looking similar. See, 1,000 minus minus 111 minus 100. It will same digits we get actually, but in a different way. The process is different. Procedure is different. Here you simply this minus this we do 787. Here when you multiply this thing, it gives a carry. It becomes actually. See again we if you do not you don't want to do it in a conventional method, we again follow a Nikhilam Navatas Charamodasata. It is above base. So 11 above base and is 2 above base means 100. And we earlier we did this plus this, so 113 and 22. Now 11322, this is the result. But here it is 3 digits are allotted from the right part, AB part. So 322 we write like that. 11 we write as a carry below the earlier this n a minus n minus a minus b part. So this is the one, and finally we get the result. Now you please tell which one. There are 2 more I have to see. This is my conventional method. What you did with a lot of calculations have to be done, but conventional method, but using vinculum. Since it is 0, already I skipped one line, directly we put into 2, shifted into 2. There is one more shifting is there, the next digit. So this one we using vinculum, a conventional method using vinculum we do, and so we finally get the same result obviously. But you tell me now which is best out of that. It will depend upon case to case. I do not say, I cannot say that in this particular method is better than that particular method. It depends upon the numbers given. Sometimes conventional method may be also good. We do not keep away from conventional method. Always we take it along and always have multiple. As I told, doing basic mathematics means you get more control over your number system and control over the knowledge of choosing the best method in case-to-case basis. Now we please tell this 889 into 898, which you like the you thought that is best.
Conventional using vinculum is best for these 2 numbers, sir. Because it is
Okay.
easier, simple numbers, no? That's why. For these 2 numbers only. For 889, 898, conventional method using vinculum is the best, I feel.
Okay, that's your opinion. Nice, it is nice. But some people may think that, okay, this is better. Although it is going to another level, second level, but some people may like it. Some people may
Nikilam
also.
Navata, Nikilam Navata is next simpler, and then Trijaga Bhagyam is next one. It'll
Oh, yes, yes. Then maybe. Sorry. So you just presentation is here. You you try this one, and similarly you can slightly change these numbers, and you see. You can see that how you change these numbers, you make it 7 or 6, something like that, and then you again compare. You do the similar things, and
Okay.
again you compare. You will see that sometimes which is better, which is not, and then
In Nikilam Navata, sir, you have taken that 11322 you got, no, on the right side.
yeah.
So you have taken 322 because these numbers are 3-digit numbers. 11111.
Because it is no, there is 3 zeros in the base. Base
Okay.
is 1000.
Yeah. Okay.
Base n is 1000. So there are 3 zeros. So
Okay.
there are 3 places allotted for that right part, AB part.
Okay. Remaining you will take as carry.
Remaining have to take as carry.
Okay. If it was 10,000, we would have taken 4 numbers.
Yeah.
Okay.
Okay. So this, I think, you can see it again. Today I just, yeah. Now, as I discussed, the algebraic comparison of multiplication algebraic. So, as I told earlier, that given 2 numbers, this kind of notation means actually 8 into 100 plus the ABC and PQR. The next slide. Oh, sorry. These A, B, C, and PQR. Those of you who are not accustomed much with algebra, this is like 8 into 100 plus 8 into 10 plus 9. It is 8 into 100 plus 9 into 10 plus 8. So these are actually, instead of that 8, 9, and so on, this is put as ABC and PQR, that both the multiplicants. And we do this way. And in conventional method, what we do, we first multiply everything by the rightmost digit. Everything by 8 we multiplied here. So this is, it is showing here, everything are multiplied by R. And then we are, everything are being multiplied with 9, but it is shifting one digit. So it is equivalent to this one. Everything we multiply by the next digit. There it was 9, and then we shift to one place. It is equal to multiply by 10, and then finally everything multiplied by the leftmost digit. All the top one we multiply, and then it is 100. But in Urdhva Trijagabham, we group the 10,000 part is coming from the two leftmost digits, A and P, coming from only this one, 8 into 8, from the two leftmost digits, which will become, this one, 8 into 8 becomes 64, this one. So it becomes 64. Then you come to that, this part, AQ plus BP, across one, with involving 2 towards left. Then the involving 3 cross, AR plus BQ plus CP. This cross was there. Then again 2 crosses there, BR into CQ, BR plus CQ, and then CR finally, the rightmost digit. So that way we add, and this is more efficient as I told. So that way this is algebra of the methods. These 2 slides, if you master fully, these 2 itself, if you fully master, then you can compare it and appreciate all the different methods. I think slightly changing the numbers, as I told, you complete all these things, you repeat all these with change number, and you see that how different method. You also, in the process, you learn a different method, multiplication method. Now today I am going to division. Division by Nicolam method. Again, division by Nicolam method. 1 minute, please. So again, that question is that what is nearest power of 10? So we start with the most simplest one. It is simply division by 9. So nearest power of 10 is here is 1. So this 1 is put here. Just 1 is the deficiency from basic purpose of division is to find here. We do not go up to fractional level. Basic purpose of division is to find simply quotient and remainder for any given dividend and divisor. In Nicolam method, result of deficiency of the divisor from the nearest power of 10 is worked with. So we do not exactly do the table of 9. That is the thing. We don't have to use table of 9. Instead, we do table of 1 because it's 1 is deficient. 1 is the deficiency of 9 from the nearest power of 10, which is 10. 10 minus 9 is 1. So it's 1 is the deficiency. So what do we do? We simply multiply by 1, 3, and put it in in this case, directly putting it on the remainder side. Now, here the logic is there. Had this 34 be divided by 10, so what will happen? 3 will be my quotient and 4 would have been my remainder. We put a line. This line is put the dividing line between quotient and remainder. Now what you do? Instead of here I am dividing 34 by 9, not 34 by 10. 34 by 10 gives this quotient 3 and remainder 4. But here, since I am dividing by 9, in every 10 there is a deficiency of 1, and it will be more than this. This will contribute towards the remainder. So it becomes 3 and 7. So if we divide 34 by 9, the result is that quotient is 3 and remainder is 7. So this one also same one. This 6 is simply, I do not put 1 everywhere. Actually, 1 can be everywhere. But I know that I am multiplying by 1, so no problem. 6 into 1 is 6. 6 is my quotient and 7 is my remainder. 123 divided by 123 divided by 9. This 1 comes here. This made it actually 7. This this made it 3. The 3 actually there is. We could have written below also, but it is also can be, since it is only this one. In case of 9, it can be written straight. This 2 plus 1, 2 plus 1, when multiplied by 1 becomes 3. This is written here. So finally, we added plus 3 is 6, plus 1 is 13, and 13 is my remainder quotient, and 6 my remainder. There can be 2 levels of calculation when the remainder becomes more than 9, more than the divisor. This is dividend, this is divisor, this is quotient, and this is remainder. These are the things only in the in case of division. Those are the only things to be considered. Now 253, 253 divided by 9. What do we do? The 2 into 1 becomes 2. This 5 plus 2 goes to becomes 7. Now this puts my result as, for the time being, 27 my quotient and 10 as remainder. Again 10, when you do, 10 is basically more than 9. So again we played with that. So to 1, calculate that 1 into this 1 becomes 1, and this becomes 1 as quotient and 1 as remainder. This 1 quotient gets added to the previous quotient and becomes 28 as my quotient and 1 as a remainder. 9 into 28 plus 1 is 9 into 28. The idea is this 9 into 28 plus 1 is equal to 253. That is the quotient, remainder, and so on equation. This part is clear? This came only when the remainder became more than the divisor, means 9. So I'm going to do second level. Now I come to more example, you will find it. Actually, purposefully, less numbers are given here. Every time you get more than more than 9, it's to understand the procedure. These small numbers are put. Actually, with bigger numbers, it can be different. Always you have to put maybe 2 levels, 3 levels, and so on. It works for that. See, I am not ruling out the use of conventional division method. Conventional division method may be also good, but here there actually we have to you have to use tables of 9, 8, 7. Here actually you are getting we are doing on the reverse one, the table of 1, 2, and 3. These kind of smaller numbers. It is the opposite. Here again, see here 1 into 1 is 1. I will not always say 1 because in case of 9, it's, multiplied by 1 is implied. This 1 I put here. 1 plus 2 is 3. We put here. 3 plus 3 is 6. We put here. 1 plus 6 is 7. We put here. When you add finally, we go 2 plus 7 is 9. 1 plus 6 is 7. 3 plus 3 is 6. 2 plus 1, 3, and 1. So 1, 3, 6, 7 is my quotient, and 9 becomes remainder. Again, 9 cannot be remainder, becomes contribute 1 more towards the quotient, and finally my 1, 3, 6, 8 is my quotient, and 0 is remainder. Here we come 1, 2, 0, 0, 2, 1 divided by 2. Unnecessarily, we have to do lot of tables of 9 dividing this one. But here you see directly it is very straight. 1 comes here below 2. 2 plus 1. 2 plus 1 comes below 3. 3 plus 0 is below this 0. 3 plus 0 below 0. This again 3 plus 0 is below this. 2 plus 3 is 5. 5 is here below 1. 1 plus 5 is 6. So it becomes below the remainder. So the whole number 1200212, it was the number. So when divided by 10, we would have gotten 120021 as my quotient and 2 as the remainder. But here is the procedure by which that deficiency of 1 in the 9 is contributing towards various levels, various powers of 10, various position values. All these numbers are getting contributed, and finally we are adding it. 2 plus 6 is 8. All these add, and finally you get the result 13356 as the quotient and 8 as the remainder. Here also, here another example is there. 1 comes here. 1 plus 0 comes here. 1 plus 1, 2 comes here. 1 plus 2 is 3 comes here. 3 plus 6, 9 comes here. 9 plus 4, 14 comes here. 13 comes here. 13 plus 9 become 22 as my remainder, first level remainder. This becomes quotient. And again with 9, 2 and 2 we do, and it becomes 2 and 4, 2 my quotient remainder. That 2 contributes towards the previous quotient, previous quotient, and this quotient gets modified, and remainder becomes 4. Any questions here? Division by 9.
I think there
Okay.
are no questions.
No, clear, sir. Clear.
Okay, thank you. Now we come to next one. Division by 8, 7, and 6. As you shift from the power of 10, this method actually gives more complications, becomes very easy. So there are other methods called even conventional method is there. There are other methods, straight division, which will be taught in the next level. So any other method can be done. Nicola method works best when it is those things are there. The divisor is near about power of 10. How much near, that depends upon your skill, how much you can handle. Now 8 is too deficient from power of 10. So you have to multiply by 2. 2 into 2 is 4. So here we get 2 as quotient and 7 as remainder. Here 31 divided by 8. Again, I repeat that 31 had then been divided by 10, would have gotten 3 as quotient and 1 as remainder. We put this line always between the quotient and remainder. Now here 2 is the deficiency, so 3 into 2 becomes 6, and finally 6 plus 1 is 7, and 3 is the result. 7, in case of 7, this 3 is the deficiency. So 1 into 3, you have to multiply by 3. 1 into 3 is 3, 2 plus 3 is 5, so it is the result. 2 and 20 by 20 divided by 7. So 3 is the deficiency, 2 into 3 is 6, so it is 2 is remainder, and 6 is quotient. Sorry, 2 is quotient and 6 is remainder. 1 here dividing by 6, 6, 4 is my deficiency from power of 10. So 1 and 4, so here 4 do and add it, and 1 becomes my quotient and 5 becomes remainder. So 234 divided by 8. So no requirement of putting the tables of 8. Tables of 2 is sufficient. 2 into 2 is 4. 3 plus 4 is 7. That's 7 into 2 is 14. 14 becomes my, here you contribute, 14 plus 4 is my 18 is my remainder, and 27 quotient. Again, 18 cannot be the remainder. We again do another level. So here actually we could have done actually on 8, this one. I already did it. This one, 8. So 2. Actually, that is why I didn't do. Again 1 and 10, but this 10 and again 10, this 0, and with 8 it becomes 1 and 1. 1 and 2. 1 into 2 is 2. So that way I directly did it. These two also no problem. Here it is so easy, small number. You know that 18 cannot be the remainder. It becomes another 2 will come. So that 2 into 8 plus 2. So this 2 is my quotient, and 2 contributes here. So 29 becomes my remainder. So 345 divided by 8. So again, 3 into 2 is 6. 6 plus 4 is 10. 10 into 2 is 20. The 25 becomes my remainder, and 40 quotient. Again, 25, as you know, 3 into 2 plus 1. 3 into 8 plus 1. So it's 43. 3 more contributes, and 1 is my remainder. This also you could have done 25 this way, like it did 23. We could have done by 8 is 4 and 9. Again from 9 cannot do by this method. 9 we know very easily. Simply subtract 9 minus 8 is 1. So this 1 and 1. That you always apply your knowledge wherever available. Always don't have to stick to, okay, this have to be done like this. Therefore, I jump the step, no problem. because we know it already that 18 remainder means what? It will be again reduced from 25 remainder, how to make it only 1 remainder and 3 as quotient. We already know it, so directly you can jump the steps, no problem. Now, up to here, I think there might not be a problem, but now there can be more. We'll go to the next level. Division by 2 or more digits numbers requiring only single processing. This example is 111 divided by 89. So it is 111. The nearest power of 10 from 89 is 100. So had we divided 111 by 100, we would have gotten 11 as my remainder and 1 as quotient. So we put this dividing line accordingly. In case of numbers which is near to 100, we have to leave 2 digits and put the bar here on a dividing line. And then 89 is 100 on 11 division from 100. So we simply multiply these things, this one by 11, and 11 is multiplied, we put directly below the remainder, and remainder becomes 22. This is a contribution basically coming from 11. Now, 222 divided by 87. So 13 is the deficiency from power of 10, means 100. So 2 into 13 is 26. The 26 comes below. This is the total remainder becomes 48, and 2 is my quotient. 333 divided by 12. So 3 into 12 is 36. This 36 added to this one. The had it been divided by 100, that earlier remainder, this adds to this remainder, and 69 is actual remainder, and 3 is my quotient. 888. 1, 2, 3, 4 divided by 888. 112 is the deficiency from the next on a nearest power of 10 means 1000 here in this case. We put also accordingly 1000 is the nearest power of 10, so we leave three digits for remainder, and 1 into 112 is 112. This plus these are small examples, simpler examples are discussed to give you the idea that what is the procedure. When the procedure is important, first you learn the procedure without any much complication. So 789, 211 is my your deficiency from nearest 1000, and so it is basically deficiency means what? 1000 divided by 789. Nikhilam Navatas Charmadasata is called the same thing actually, 211. Or Nikhilam Navatas Charmadasata. This one is getting subtracted from 10, so 1. This is getting subtracted from 8, is 1. This is getting subtracted from 9, so it becomes 2. Always use that. Deficiency I'm telling, but actually it is Nikhilam Navatas, single digit, obviously it will be from 10. When there are multiple digits, the rightmost digit is subtracted from 9, subtracted from 10, the others are subtracted from 9. So this last one is from 10, this is from 9. So that way, this is from subtracted from subtracted from 10, this is from 9, this is from 9. So therefore, it is called Nikhilam Navatas Charmadasata. Sorry. So any question here? 211 into 2 is 422.
I think now.
Yes, sir.
Any question? I think there are no questions. It's 5 to 8. we'll stop here for questions. Anyone, or we move forward? There is someone raising the hand. You can, Bappa Bhattacharya ji, boliye.
Please, Bappa ji, boliye. Namaskar.
Namaskar, Gautham sir.
Hmm.
One question is that is not related to this method which are being taught now. That nowadays we are using in case of any calculation, either calculator or computer through Excel method, etc. That calculator or computer, which logic they used to follow, either this Nikilam method or this or conventional method. Suppose if that instrument devices are prepared, manufactured based on this method, what will be the benefit we will derive?
It is actually difficult. Programming have to be done that way. That if it is near about a 10, but actually, as I told that in case of multiplication, Tiryak method is the best one. But division actually, this one will be very little applicable. There
Now,
can be
that is when we are calculating manually. Suppose if we calculating through calculator or computer, is there any basic difference between these two methods? Just it is my personal academic interest.
No. It's not calculator. Using calculator, you are not using method. It depends upon what is in the processor that you don't have any control.
That's what I'm telling you. The processor is using that conventional method. Suppose if it is used in Vedic method, will there be any benefit or any software length?
That somebody has to do research on. I cannot tell it directly. Somebody has to do research on this division, because somebody did research on multiplication method, and there is found that Urdu Trijagabham is the best one. Here, similarly, somebody has to do accordingly many programming.
Okay. Thank you, sir.
Okay. Any other question about the procedure? Directly this procedure. I hope it will not be a problem. I go to next one. Example, here it is division by 2 or more digits number requiring single processing. Now there can be multiple processing, I tell you. There may be multiple processing, multiple lines, and then the multiple processing also. So this 1111 1111 is being divided by 89. So 1 into 11 is 1. 1 plus 1, 2 into 11 is 22. Now here, there is a catch. Actually here, so far we didn't come across this one. Here, part of the thing is coming in quotient and part is remainder. Mind it, although I'm writing 1 here, actually there is a invisible 0 is there. This I've seen, calculators or algebra, I found that is okay. And and then we do not write that 0 also. But it is the digit below this digit. And then 1 plus 1 is 2. And then 2 into 11 is 22. So then again 1 plus 2 is 3. 1 plus 1 plus 2 is 4. So 12 is my quotient and 43 is remainder. We come to another example. 2, 1, 4, 5, 6 divided by 7, 8, 9. Nikilam Navatasya, this is subtracted from 10, subtracted from 9, subtracted from 9. So 211, my deficiency. So 21, 2 into this one, 211, 422. 4 and 22 here. 1 plus 4 is 5, and 5 into this 211 is becoming 10, 55. 6 plus 5 is 1, 11. 5 plus 2 plus 5, 13. 1 plus 1, of course, 3, 13. 4 plus 2 plus that one is 7, and this one is 1. This becomes my remainder, and this my quotient. But here again, multiple processing I told. So 1731 again is divided by 789. It becomes 1 and 211 becomes 942. You simply you do 942 42 minus 789. Okay. We do 153, and these two will contribute. This two will contribute to the previous one, and to 27 will be quotient 153 my remainder. However, in the multiple processing, you have to collect all these quotient. It will contribute towards quotient always, and it has to be collected. So here also 1, 2, 1, 4, 5, 6, and 21. Time 756. Okay. Now this one we similarly did this 211 place 1 into this thing. 2 plus 2 is 4. 400 is 844. This one 1 plus 1 is 10 to 2110. Or you subtract all these. We add all these things. 3106 150. Then 3106 again became 3 and 739. So 153 and this one. Here, if we change slightly these numbers, instead of 1, 2, 1, 4, 5, 6, I did 2, 3, 1, 4, 5, 6. We require 3 levels of revision. I put another one example. These are just in short. I do this one longer complication. I told it longer complication. Tomorrow actually we'll discuss in detail. So this one, if we see that there is one level, then another one, and final. There are 4 levels. The final quotient becomes 4 things added. Final quotient becomes this, and remainder is this one. Best Vedic method is state division for the above problem. So that will be in the second level course, state division or the conventional division. No problem. There is nothing, say, untouchability about Vedic, non-Vedic, conventional, unconventional. There's nothing like that. What is the best in case-to-case basis? Whatever best you like, you always do. But it is the best way to learning. When it is better to learn all different methods so that you can do it on particular cases. I stop here today.
Okay.
Any
Babu,
questions?
Thank you so much. Gautham ji, thank you so much. I will exit this presentation.
Okay. Yeah.
Okay. Now, if there are no questions from the students, we will go for Prarthana, and then after that Janaganman. Vishalakshi ji, are you there?
Yes, sir.
Okay. I spotlight you. Please chant Prarthana.
ॐ स्वस्ति प्रजाभ्यः परिपालयन्तां न्यायेन मार्गेण महीं महिषाः गोब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथ्वी शस्यशालिनी देशोऽयं क्षोभरहितः ब्राह्मणः सन्तु निर्भयाः अपुत्राः पुत्रिणः सन्तु पुत्रिणः सन्तु पौत्रिणः अधनाः सधनाः सन्तु जीवन्तु शरदां शतं सत्यं वद धर्मं चर स्वाध्यायान् मा प्रमदः सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत्। ॐ शान्ति शान्ति शान्तिः। ॐ पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते। ॐ शान्ति शान्ति शान्तिः। सर्वे जना सुखिनो भवन्तु। स्वस्ति।
Swasti. ధన్యవాదములండి చావలి విశాలాక్షి గారు. Now let us recite national anthem. Challa Chitbabu garu.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता। पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल बंगा। विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा। तब शुभ नामे जागे तब शुभ आशीष मांगे। गाहे तब जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे जय 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 हे जय हिंद।
ధన్యవాదములండి చాలా చిట్బాబు గారు.